I welcome you all to the Spark Research YouTube channel. This is Dr. Vichandra, Assistant Professor in the Department of ECE, and here is the another session for this particular course, Signal Processing. And this is the special session, and here we are going to take some questions which has already been asked in the previous year, right? So these courses, the signal processing course, will be helpful for your GATE exam preparation. So if you want to prepare for your GATE, definitely you can join this channel. So let's take the questions. So first of all, let me tell you this. The exam will be of 75 marks, total marks, and since I have already uploaded the one similar video, the related to the 2025, and this is the pass to pass, so 2024. So almost similar pattern is there. So total question will be total question will be of 75 marks. Out of that, there will be the two sections. So part one will contain the total 1 to 7 question, and out of that you have to solve how many question? 5 question, and each question will carry how many marks? 10 marks. So you can score 10 into 5, that is 50 marks from part A. And part B will be of how many marks? 25 marks. And 20 out of 25, like for 25 you will have the two option, either 8A or either 8B. So you can solve any one of them and you can score the 25 marks. So total 50 marks for part A, that is from question 1 to 7, and part B, that is question number 8, that will carry the 25 marks. So total you will get the 75 marks. Okay, so let's take the question. So first question is here, you can see, test whether the following signals repeat after a definite time period t, or n. T for continuous time and n for discrete type of the signals, if the signals are periodic, and determine its time period. So you have to find whether the signals, whatever that is given, is this periodic or non-periodic. If periodic, then what is the time period, or n, and if it is non-periodic, then that's good. Okay, so here, which of the following two signals are the energy, and here you have to find whether the signals are energy type of the signals or the power type of the signals. So these are the questions related to the periodic and the energy signals. So let's see how to solve. And another question in this same, that part third, is that find which of the two signals are energy and power. So same questions. Okay, so let's see. So first of all, how will you find whether the signal is periodic or non-periodic? So for periodicity, like xt plus tau should be equal to tau. So here, since e to the power minus t, you can draw the graph. It clearly depicts that this is non-periodic signals, right? So also if you put it here, you will get not repeated. So this is non-periodic. For second question, like this is your 2i's cos of and 3 e to the power z. So for that, if you'll put the the same xt plus tau x, since this is discrete now, so x of n plus n is equal to x of n, then here you can get the periodic, right? This is going to create the first part. This will be periodic with the 6, n is equal to 6, and second part will be the periodic with the 8. So LCM if we will take now, then n will be 24. So this is the periodic function, right? And similarly, we are going to take the second question. Here we will decide whether the signal is energy and power. So first find out the energy. Energy is equal to, remember the equation, E is equal to integration of minus infinity to infinity xt square and dt. So integrate it just, and if it is finite number, then it will be energy signal, and if it is not finite, then you can calculate the power, right? Power means limit t tends to infinity and 1 by 2t, and they integrate it minus t to t xt l square dt. And if it is a finite number, then that will be the power signal. In short, this is very simple to find. Actually, for any periodic signal, right? For any type of the periodic signal, that will be the power signal. And if it is non-periodic, non-periodic means like these type, like exponential type of the functions. These are non-periodic. For non-periodic, the signal will be energy, right? So non-periodic almost energy, and periodic almost power. 90% it will works. Okay. Here unit step signals. So in this case, since this is periodic itself, so this is very simple, and this is the periodic function, right? Okay, next question. Here given below the two signals systems are given, yt is equal to xt minus t and plus x of 2 minus t, and another signal is given. So here question is asking whether the system is following the principle of superposition and time invariance, right? So how will you check whether the signal system is the following the superposition or not? So test linearity, right? So test ax1t plus ax2t is equal to a1 y1t and a2 y2t. It should be there. If it holds, means that will satisfy the linearity principle. So this is satisfying, right? For second one also, if you will check it, so here like if you'll put it like on the same, then definitely only one term is there, so it will also satisfy. So both are the linear only. For time invariance, now shift in the time and check whether is this equal or not. So here this will not satisfy the time invariance. So this is time like not invariance. And second one, there is no, like even if you are changing in the time, the slope will be fixed. So no changing in the slope. So that causes time invariant. Okay. So next question. So two signals are represented in the time domains. This and what to do here? You have to convert given signal into the equivalent frequency domain representation by the Fourier transform. Right. So signal is given here, and how will you solve using the Fourier transform? So Fourier transform, like whenever you have wanted to change, then use this equation. Equation is x of omega, that is in the frequency domain, integrated over minus infinity to infinity and xt e to the power minus j omega t dt. So multiply by e to the power minus j omega t, this term also from here, and then integrate it. So if we will integrate, after the integrating, you will get the x of j omega. So that is the Fourier transform. Similarly, for another question, you can see here, you can again transform it. So multiply by the e to the power minus j omega t and integrate it over minus j omega t, and you can also solve it using the property. So final result will be 2a divided by a square plus omega square, right? And like this is the actually the results, and you can use this property and you will get the final result. Okay. Next question is related to the 8-point DFT. So here sequence are given 2 1 2 double 1 2 1 2, and right, and you have to find the algorithm, and that you have to find the sequence decimation in time. So DIT FFT. This question is related to the DIT. Already I have uploaded one special session on the DIT FFT, and also decimation in frequency, also DIF FFT. So you can go through that session and you can check. So how will you solve? So first of all, get the the values of these W and 0, and after getting these values, you can put all these values in the one decimation in time table, like this: first radix 2, radix 4 and radix 8, and then keep on adding, you will get the final answer. So steps, like if you wanted to check the steps, you can check it here, like these are the inputs values, for example, and already in the very detail we have discussed there, right? So radix 2 is there, and radix 4 is there, and radix 8 is there. So in this way you will get the final answer here. So all these are the final answers. So how will you get? Simply keep on moving, 4 then 12, and then totally here you will get the 28. So 28, not like that, you will get it from here, like this one, right? Again, and this will depends on this. So from here you will get. Okay. So and so next question is that let the two signals are represented as here, and find the output of the signals using the suitable convolution techniques, right? Solve using the linear and circular method. So how to solve the linear and circular? So again, there are the two methods, like linear and circular. So this technique you can use as a linear, and circular we have already solved the previous question, previous session also, like in the previous lines also you can check that how to solve. For linear also, you can put the inputs and another two h of n and x of n here, and then you can get the y of n here, right, after multiplying. So if you multiply and keep on adding, you will get the values. Clean. Circular convolution also, like just keep on rotating like your x of 1 h of n or x of n. One of you can keep on rotating and adding. And if you'll keep on adding, you will get the circular convolution output. Right? For detail, you can check the previous one. Okay, so here you have to design another Hamming type of the filter, and filter length is given, frequencies is given, right? Upper and lower cutoff frequencies and the sampling frequencies, everything is given. You have to design the Hamming type of the filter. So how will you find out the Hamming type of this filter? So actually you have to use the h of n, and this is the major equation, right? H of n is equal to h of dn and the wn. HFD, you have to find it for your filter, and so here HFDN is for your the sinc function. This that is sine of omega n minus sine of omega 2n divided by pi n sinc function. So from here you can get the HD of n, and then window function, like since question itself is given window function Hamming. So for Hamming function you have to remember this type of the equation, right? Wn is equal to this one, and then further multiply and you will get the final filter, right? In the frequency domain, in h domain you have to get the convolution. Okay, so in summary, here I am just going to show the different type of the window. You can refer to the again the regular slides we have already discussed. So Hamming window. So this question is related to the Hamming window previous. So you can check the equation. Similarly, the questions may be the rectangular, Hamming, and the Blackman windows. So you have to use these equations in that case. Here the graph for the different types of the window techniques. Okay, so next question is related to your infinite IIR filter design. You have to design the IIR filter for analog filter designed to require Butterworth low pass filter, right? So here Butterworth low pass filter you have to design, and that will convert analog filter into digital using the bilinear transformation. So bilinear, exactly, you have to remember one equation whenever it will come. And what is that? So here is the bilinear transformation equation. S is equal to 2 of 1 minus Z inverse divided by 1 plus Z inverse. This is nothing. This is converting from S domain to Z domain. S, that is Laplace transform, and Z domain the Z transform. So that is only nothing else, right? And so how will you convert? So use this pre-vector equation. Already these equations we have found, so use that equations and get the final value of h of z after transforming into the z transform. And one last eighth question, given the time domain x of n is given and the signal representation in the frequency domain given, and what to find here? Convert given signal time domain and the representation you have to find in the inverse transform, nothing else, right? And you have to find the sum output. The transfer function is given and inputs are given. So for inputs are given transfer function, so just multiply like inputs with the inputs in the frequency domain with the h of s, right? Multiply and you can convert back into the time domain. So this is the steps. And here in order to find out the inverse, use a partial fraction method. So that is the simple technique, right? So here in order to get the inverse, we can use this partial fraction technique. Here just first write down a and b in terms of that, and then find out the value of a and b, and then convert it in the known form, and then finally you will get it the final answer, right? And for some given inputs, you can get the outputs by multiplying in h of s and then convert back into the time domain using the same partial fraction. Right, here again h of s you can use and convert back into the time domain. So very simple equations, right? Okay, so again another question is related to the DIF FFT, that is decimation in frequency, right? This is not the decimation in time related question. Here analog filter you have to design the Chebyshev filter. So DIF you can check, this is 8 radix and then 4 radix and then 2 radix. So just reverse to the DIT, right? So you can check the special session on the DIF, right? So in more detail how to solve the question. Okay, then the second question is KYC filter. So in that case you have to remember the one equation, that is how to find the KYC filter. And for more details, again, you can refer to the contents related to the JavaScript test that we have already discussed. Okay. Okay. Thank you to join the session. In this session, actually, I try to highlight the only the particular questions that will be helpful for you to prepare your exam. Okay. If you have any doubts, drop. I may bring the the more discussion session on the related questions. Right. Probably I will bring the gate questions as well related to the signal processing course. Right. Okay. So you may too. Thank you.